is a little bit different. It's supposed to be informal or just spark discussion throughout the day. The idea is to call it a tool demo, so you can use it actually to give a little bit more information about a specific aspect of a tool that's going into your pitch project. Or you can tell us about anything that is interesting to you that you think is information that the general audience would enjoy. And hopefully it drives into discussions that we might want to have over lunchtime in the Discord space. So I want to say this is really an open platform. I know there's a couple people that I voluntold or strong-armed into giving tool demos. I don't know if any of those people are willing to click on the share audio video button right now to come up on the stage and do their demo.
Hello.
Yeah, you did it. I knew it. I was like, yay for the voluntold.
Okay. One second. Let me see. Do I just start? Oh, Aaron, you're on mute.
Yeah, I think you can go ahead and just start. Well, maybe I'll introduce. This is Ruchi for anyone in the community and in the audience who doesn't know her. She's a new postdoc, actually in my lab or joining the Kimmel lab at CAMH. Just joined in September, and she has a lot of knowledge about multivariate stats. So we might call her New Derek now that Derek has left the community for another job. And asked her to bring back the tradition of talking about multivariate stats or educating about multivariate stats a little bit. So yes, I will let you take the floor.
Sounds good. Okay. Let me try to share my screen. Wait. Okay. Second. Do you see my screen? Okay, cool. So today I'm going to share about this tool. I think several of you might have already knew it from Derek and Jenny. So this is called DiSTATIS, and it will give you a beautiful firework plot like what I have right here. So I'm going to walk you through what DiSTATIS is doing and what we will see from the output and the resources. Okay. So what is DiSTATIS? It's a component-based analysis when you want to analyze multiple matrices. It could be distance matrices, correlation matrices, covariance matrices, and so on. It just have to be symmetric and square. Okay. So if you're using DiSTATIS, that is when you have distance matrices. If you have correlation or covariance matrix, DiSTATIS could take care of that as well. But Derek and Jenny then develop this more specific type of DiSTATIS for correlation covariance matrix, focusing on neuroimaging analysis. That's CovSTATIS, and I think several of you might be more familiar with this than me because C. Mariner has been a pitch project for BrainHack Toronto in the past few years. So with these, we could apply them to sensory evaluation for the sorting task. So this is the more common use in the psychometrics tradition. So people will, for example, they will drink 10 glasses of wine, which is fun to do for research. And then they try to sort it out, right? So you will see they try to put 10 glasses of wine into, for example, 3 groups. And what they will do is they will quantify them by taking the distances. So if you're in the same group, you will have 0, so mean 0 distances, which means you're the same. If you're in different group, that would be 1. And then they will use the status to analyze this type of analysis when people sort things. And there are also recent application to brain network analysis using them, because as you can see, connectivity, well, correlation or covariance is also a way of quantifying distances. So you're trying to evaluate how similar these different observations are. So in DiSTATIS, we'll start with the acronym. It's French, and I'm not going to talk about that. It's just that, okay. And so it works on distance matrices that mainly measure similarity, and it could also be correlation matrix, which implies that. And when you work with a single matrix that looks like that, you do multidimensional scaling. And DiSTATIS is when you have multiple matrices like that. So you could do a joint analysis of all of them. So it works on multiple connectivity matrices. I would call it a 3-way MDS. So for example, if this is what you have, so you have 9 participants and you scan resting state functional connectivity, and these are their connectivity matrices. Oh, one thing to be aware of is that when you analyze these matrices, you need to have matching dimensions. So the rows and the columns need to be the same across all participants. Across all tables, it doesn't necessarily have to be participants. So what DiSTATIS do is to identify a common pattern across these matrices by emphasizing the one who has the more common pattern, and also weighting down the outliers. So after you do dimension reduction method, what it will tells you is how similar these nodes are based on the common connectivity pattern. So for example, here I'm plotting like the mean factor scores of different networks from the Gordon parcels. I'm just using this is the Midnight Scan Club. So from here, we could see that, for example, on dimension 1, default mode is opposite from singular picular network, and this is different from or orthogonal to dorsal attention network. And on the second dimension, you have dorsal attention versus ventral attention or auditory. And what you could also do is to build back the low rank matrices to find out what each dimension represent, what pattern each dimension represent for. And the new thing about DiSTATIS is that you could also look at how these nodes look like from the perspective of different tables. So in this example, of different subjects. So it will give you the firework plot like that look like this. I think we call them either spider plot or a star plot. So for example, this is dorsal attention, right? So the triangles here are just the mean factor scores that I have right in this plot. And for example, this is how subject 3 well, let me rephrase that. This is how dorsal attention is being seen by subject 3 and by subject 9 and so on. So with this, you can see that, for example, subject 3 is driving the second dimension, and second dimension is pretty much characterized by this kind of pattern and so on. And in some cases, you would also see, for example, more variance for some network as opposed to others. So this also let you look at individual differences at the same time. Another thing from the status is that it measures RV coefficient between these tables. So RV coefficient is similar to the correlation coefficient between two variables, but now you just think about them as correlation coefficient between tables. And then it has this, for example, if I have 9 tables, I have a 9 by 9 RV matrix, and an eigendecomposition on that is included in the status, and that would give you also a map of how similar these participants are. So we usually look at the first dimension, so they're pretty close. So just a heads up, we in this example that I'm showing, I took out subject 8 from MSc, which who fell asleep during the scans. And so you don't see much difference, but on the second dimension, so after we extract something that's common for everyone, you start to see the separation. So there are 2 clusters of people that might behave slightly differently. Okay, so finally, the packages for these are, so the status, and the one that we have currently on CRAN is outdated, and the version on this GitHub is being updated, and we'll keep like revising it. So that's the status R, and also CovSTATIS if you want to focus on covariance or connectivity matrices. And these are the references. And if you're interested in this method, you're welcome to chat with me on Discord or further discussions. That's all from me. Thank you.
Okay. So
what do we do now?
See if I want to tell everyone you can ask questions in the polls or the Q&A, or this is really just an intro to Ruchi too, to say come talk to our Discord about cool multivariate stats method, and how they can be used. So I guess because you showed an example with like 10 people, but how would you imagine this like scaling up to hundreds or thousands?
So you will end up with a very messy map. Like it will look, you just have a ball in the center of the plot. So usually what we do is, actually I do have something similar to that. So the node that I'm showing you now are the networks, but there are actually several nodes inside each network. And so you use them to plot confidence interval around these group mean factor scores. And you could do the same thing with the participants. So instead of plotting everyone, you could. So what I usually do is I will first show the individuals points and then just color them differently. So from the distribution of the color, you might be able to see a general pattern. And then I'll go on and compute mean like group scores for different group of participants and plot them and try to simplify the plot. And if the plot is not a good way to show it, there are other ways, but you ended up quantifying their commonality and differences, and you could run tests on them.
Cool. Do we have any more questions on Ruchi from people who are like excited to ask questions on this Hopin platform? I know it might be easier to ask questions in a different space. Yeah, it looks like that question's from yesterday. Wow.
Yeah,
Yay.
if anyone has any questions, I'll just be on Discord and
Cool.
ready to talk.
Yay. And you'll be around for the day too. So if you show up at Distillery and you
Yeah.
have nagging stops questions that you feel better asking in person, you can make fruit cheese
Yes.
stroll through the distillery very interesting. Anyway, okay.
Yep. Oh, I might not be joining the
Oh,
distillery trip tonight. I'm still having some like cold symptoms, so I don't want to risk that.
yeah. Okay.
But
And
yeah, I might be on site at some point. I don't know when.
okay.
Yeah.
Cool. Yeah. Okay. Do we have anyone else who's willing to give a talk? I know we maybe strong-armed Johan into telling us a bit more about the APIs that he wants to use in his BrainHack project. Let's see if he's... Actually, we might leave the screen to snapshot this video. Yep. Okay.
Okay. Leave.